Okay, so this is the 2010 FRQ differentials number 6. Okay, so the question is solutions to the differential equation dy dx equals xy cubed also satisfy dy squared y over dx squared equals y cubed, open parentheses, 1 plus 3x squared y squared, close parentheses. Okay, so let y equal fx be a particular solution to the differential equation dy dx equals xy, that is a xy cubed, with f of 1 equals 2. Okay, so I already boxed in a couple of things that we need to look out for. So this is the derivative right here. Then we're also given the second derivative. No need to do it again. And then we're given this is going to be important for the first part. So okay, so the first part is write an equation for the line tangent to the graph of y equals f of x at x equals 1. Okay, so we're going to write an equation line. We have our 1 and our 2, as I said before. F of 1 equals 2. But what we're missing is the slope. And I got 8. So I'm going to tell you guys how I got 8. So basically, this is the slope function right here. And we just substitute in our coordinates. And we get 8. Okay, simple, right? So now we're just going to substitute these numbers into our equation. Y minus 2 equals 8 over x. Not over, open parentheses, x minus 1, close parentheses. Box in your answer to make sure the reader knows what you are doing. Okay, letter B. Okay, so let's read it together. So use a tangent line equation from part A. So right here, part A, to approximate f of 1.1. Okay, so that's period. So that's the first thing we're going to do for this letter. So we already have our equation line right here. All we have to do is substitute our x, 1.1, as previously mentioned above. And so we subtract 1.1 minus 1, which gives us 0.1. Then we multiply it. You know, you could do this on the side of your paper, but you cannot use a calculator as this is number 6. Okay, so we get 0.8, and we're trying to leave the y by itself. So we just we add 2 and then to the other side to cancel this right here, and we get an approximation of 2.8. Okay, box in our answer, done. Okay, so now we move on to the second part of the problem. So given that f of x is greater than 0 for 1 less than x less than 1.1, is the approximation for f of 1.1 greater than or less than of f 1.1? So we're going to have to explain our reasoning. And so we know that the slope right here of 1, as we did before, the slope of 1 is 8. It's a positive number, so it's an increasing function. So concavity can tell us whether the approximation is less than or greater than. So we're going to find the second derivative, but we don't have to find it, as I said earlier, because it's already given to us. Okay, we plug in our x and y coordinates to the equation. Okay, and since all these numbers are positive, you don't have to do the algebra. It's going to be greater than 0. Okay, so since f is concave up and the tangent line lies below the graph, therefore the approximation of f of 1.1 is less than. Okay, because as I said before, the equation is increasing. So as my reasoning says, the tangent line lies below, so therefore it is less than. Okay, next one. So letter C, find the particular solution of y equals f of x with the initial condition of f of 1 equals 2. Okay, so this is the most important part where you could probably get your most points out of this, out of the 9 points. So here we have dy dx equals xy cubed. So we want to separate this. So we'll be doing this by moving the dy, isolating the dx over here. We get this, right? dy equals xy cubed dx. And then we bring this down over here to isolate the y, to separate the y and the x. Once you have them separate, you could do the antiderivative right here. Since this was at the bottom, I brought it to the top right here, and I made it a negative. So this is pretty straightforward, since you just have to add a 1 because it's the antiderivative. So negative 3 plus 1 is negative 2. You bring the negative 2 down here. 1 plus 1 is 2. You bring the 2 down here. Don't forget your c. Okay, so now we have that, right? So now we have our, since we were given an initial condition right here of 1 and 2, we have our coordinates. So we just plug in 1 and 2. Okay. So sorry for moving the camera so much, but we're going to make this positive again. So we're going to bring this down. So 2 times 2 is 4, 4 times 2 is 8, negative 1 over 8. And then we just plug in 1, which is going to give us 1. So now you want to isolate the c. So we subtract 1/2 right here to cancel it. And then we have to make the bottom same as this one, multiply it by 4. So negative 4 plus negative 1 is negative 5 over 8. Cool, now we have our c. So once we have our c, we could plug it back into the original equation right here. Change the c and just plug it in. Okay, so this right here is what we call a general solution. But as the problem says before, we have to find the particular solution. Okay, so we're going to have to isolate the y. So we're finding the y. Okay, so we're going to multiply negative 2 to cancel this negative 2. So negative times a positive is a negative. So we get negative x squared, because the 2 over the 2 cancel each other. And then we're going to do the same thing here. Negative times a negative 2 is a positive number. We bring the 2 here, and then we could cancel this out, and we get 4 at the bottom. Okay, cool. But now we still have the 1 at the top, right? So as we did before, we just multiplied it because it was at the bottom, and this is at the top. So we're just going to divide it. Cancels each other. So we're going to divide everything on this side, on the right side, by 1. Okay, cool. So now we have this right here. But we want to have to cancel the squared, so we do the square root. Okay, that cancels to leave our y by itself. So we square root the whole thing. The last important step is this is a positive or a negative because it's a square root. But we know it's a positive because our initial condition is f of 1 equals 2, and it is greater than 0. Therefore, making it positive. So that concludes my explanation.